The brand new VFR1200 is a stunningly designed street bike that has the motorcycle world buzzing. There's new technology top to bottom with an all-new V4 engine, Honda's first ever throttle-by-wire system, and a 6-speed automatic dual-clutch transmission. Add to that a Unicam cylinder head design and combined ABS, and you have a high-performance street bike that is destined to live up to the hype. This compact 1237cc V4 is shorter front to back than the VFR800. The 76-degree V configuration moves the cylinder banks closer together, reducing the size of the engine. This new 1200 has the rear cylinders centered, which in turn narrows the frame between the rider's legs. The symmetrically coupled phase shift crankshaft is forged from a new high-strength alloy steel and has a 28-degree crank pin offset. When combined with the 76-degree V angle, this causes the front and rear pistons to be out of phase, with one piston at the end of its stroke while the other is at near mid-stroke. This gives near-perfect primary balance and eliminates the need for counterbalancers, allowing for a reduction in engine size, weight, and complexity. As always, the cylinder numbering is determined by the connecting rod position on the crankshaft. The left front cylinder is now number 1. The firing intervals are now 256 degrees, 104 degrees, 256 degrees, 104 degrees, giving the engine a distinct exhaust note and feel. The crankshaft chamber is sealed from the rest of the engine. A scavenge pump removes oil from the crankshaft to reduce oil drag power losses. The pump also removes some air from the chamber, lowering the air pressure to reduce pumping losses. These efforts contribute to improving power output by 5 horsepower at 10,000 RPM. It also allows the breather chamber on the front cylinder head to be reduced in size, which contributes to the compact size of the engine. Transmission shafts are located close behind the crankshaft, with the final shaft below the countershaft to reduce engine length. A single overhead camshaft is mounted directly over the intake valves and opens 2 intake valves per cylinder through shim under bucket adjusters. Integrated roller rocker arms with screw-type adjusters actuate 2 exhaust valves per cylinder. This Unicam technology saves weight and space over a comparable dual overhead camshaft design, while still allowing a 5-digit redline of 10,200 RPM. The VFR1200 has a compression test spec of 232 psi, which is the highest of any Honda motorcycle. The cam timing index mark is at 12 o'clock on the manual transmission VFR and at 6 o'clock on the DCT model. There are new timing marks on the crankshaft rotor and camshaft sprockets. MT for manual transmission, and AT for automatic transmission, RT for rear TDC, and FT for front TDC. The VFR1200 has a new continuously monitoring oil pressure system. In previous systems, the oil light was controlled by a pressure switch that opened at 2 to 3 psi of oil pressure. In the new system, the oil pressure and engine RPM are continuously monitored and compared to limits in the PCM. If the oil pressure moves into the blue area, the oil light comes on, warning the rider with enough time to slow down or stop to prevent engine damage. The lubrication system includes both a pressure delivery pump and a scavenge pump to pull oil out of the crankshaft chamber. The pressure pump supplies oil to all of the critical bearing surfaces. The scavenge pump clears the oil out of the crankshaft chamber and delivers it to lubricate the transmission gears and shift forks. The VFR1200F is equipped with an electronically controlled throttle-by-wire system. This system introduces some new components and new types of sensors. There are two throttle cables that connect the twist grip to the throttle control position sensor, giving the 1200 the same feel and response as a traditional twist grip throttle. This sensor now has two circuits sending output signals to the powertrain control module. The TCP sensor takes input from the rider and converts it to a voltage signal, which is then sent to the PCM. The throttle position sensor is located in the drive motor cover, here on the left side of the engine. It's a non-contact type Hall effect IC sensor with two output signals. As this magnetic ring on the throttle shaft rotates around the sensor, two output signals are generated. The PCM constantly compares both signals from each of these two throttle sensors to ensure normal operation of the sensors and their circuits. The PCM also uses information from the crankshaft position sensor, map sensor, engine coolant temperature sensor, gear position sensor, and the ABS rear wheel speed sensor. Based on input from these 5 sensors, the PCM operates the throttle control motor to open and close the throttle valves. Since the PCM has control of throttle opening, it can adjust the throttle valve position to maintain idle speed, and can adjust the amount of intake air according to vehicle speed and driving conditions. This has enabled the elimination of both the idle air control valve and the intake duct control valve. During hard acceleration, the PCM will only open the throttle valves at a rate the engine can accept, even if the rider turns the twist grip too quickly. The PCM also has a built-in fail-safe function that limits the engine speed or vehicle speed if a component of the system malfunctions. The VFR1200F is available with either a 6-speed manual transmission or a 6-speed automatic dual clutch transmission. The DCT model uses a transmission layout similar to the TRX420FA, which was introduced in the 2009 Off-Road and ATV Technical Update. Let's take a look at how the DCT operates. The rider can choose from 2 automatic modes, Drive and Sport, or use manual shifting with the 2 paddle shifters on the left handlebar switch. When the engine is started, the transmission is in neutral. To drive away, raise the side stand, press the ND switch on the right handlebar to engage the transmission, and then open the throttle. As engine RPM increases, the first clutch engages and the motorcycle pulls away. As the road speed increases, the PCM shifts up to higher gears to match the desired speed. Then, when the rider closes the throttle, the PCM downshifts to the appropriate gear. As the rider comes to a stop, the transmission shifts into first gear. Pressing the ND switch selects neutral, and the rider is ready to park. Now, let's take a closer look at how that works. Each clutch is engaged by hydraulic pressure, controlled by an electrically operated solenoid valve. The powertrain control module operates the clutch control solenoids to engage and disengage the clutches, and operates the shift control motor to change gears.